This is a website we found today during chat, and it deals with factor trees. A lot of my students have just done factor trees and a lot more are just about to start them, so it seemed well worth checking and sharing with you. There are two buttons here. This one is just if you want to make a factor tree on its own. This is if you want to use it for a greatest common factor, GCF, or an LCM, which some people call a least common multiple and some people call a lowest common multiple. So we'll start over here, and sometimes there's a smaller number, sometimes there's a larger number here. So we have to think, what two factors could we multiply together to get 196? So I'm going to say it's an even number, it's 2 of something. What's it 2 of? It looks to me as though it's 2 of 98. And then at every stage I get to check before I move on. Starting to get a bit easier. Still got an even number, so it's 2 of something. And I'm going to say it's 2 of 49. Now I know that 49 is 7 times 7. I just want to show you that it's not terribly scary if you make a mistake. So I'm going to put 4. And I can tab rather than clicking in the other box if I want 5. It's not 4 times 5, but we show you what happens. It gives you a bleepy noise and it reminds you that they have to multiply together to equal your number here. So I'm going to put 7 times 7, check. Now the prime factors are in the circles. These are also factors, but they're not in circles because in a factor tree we go down each branch until we get a prime number, and a prime number only has 2 factors and they are 1 in itself. So 1 times 2 equals 2. There are no other whole numbers we can multiply together to get 2. It is prime. Same with 7. 1 times 7 equals 7. There are no other whole numbers we can multiply together to get 7. So it is prime. And we have a list here. 2 times 2 times 7 equal 197, and they are all prime numbers. So we can go next and we can practice another one, or we can now look at how we use factor trees with our HCFs and our LCMs. If we hit back, we go back to Google in this case that we used to find the site. So I'm going to refresh my browser, and I've got an arrow going around in a circle to refresh, or you could press your F5 key. We're going to click the other button. Okay, so we've got 63 and it is 7 times 9. And 9 is 3 times 3. Those are all prime numbers, so we had the dingly noise that says we've finished, and we have our equation at the bottom. Well, it's not an equation because there's no equals there. Our prime factorization is here. But 3 times 3 times 7 does actually equal 63. But we're getting 2 factor trees, so when we press next, we'll get the second one. So 28 is 2 times 14. 14 is 2 times 7, and those are all prime numbers. Now you would think you could press GCF and it would do all the work for you. Not quite. What it gives us is a Venn diagram. And if a number is on both lists, we put it in the intersection. And see that it's greyed out over here. There was another 7, but that stands for both of them. And that's very handy. If there had been a 2 on both of them, we would drag that in as well. And then, even though we had a 2 and a 7 in here, and we're looking for the highest common factor, or the greatest common factor, 7 would not be the greatest, even though it was the biggest number in the intersection. We would need to multiply the 2 numbers, or you could get 3 or 4 numbers in the intersection together, because we're not looking for the highest prime factor, we're looking for the highest factor. So if we'd had a 2 and a 7, the highest factor would be 2 times 7, which would be 14. These ones go on the side of the number they came from. So this time the highest common factor is 7, and we check. Now the least common multiple, when you do it in Maths Buddy, you've got to remember to leave any out that are double ups. But we've already done that in putting this in the intersection, so we don't have to get rid of a 7. That's already been done. So we multiply all of these numbers together and we will get the least common multiple. So you see down here there are 2 7s, and in the Maths Buddy method you'd be crossing that one out because it's in the intersection, it's in both sets, but we're only seeing it once there. We don't need to cross out. So 3 times 3 is 9, times 7 is 63. In other words, all of that circle still multiplies to 63 like we thought it would. But then we've got to double it and double it again. We'll multiply by 4, whichever is easiest for you. So I'm going to say 126 is double. 252, I hope, is what I'm heading for. I'm not very good at mental arithmetic. I always like to write it down. We won. Okay, not so embarrassing. So that is our least common multiple. I hope that helps. I hope you'll try it and compare it with the Maths Buddy method and see why it works. I think it's a super helpful website. Do several variations on each so that you get ones with 2 or 3 numbers in here and ones with no numbers over here in some sets, and see all the different ways it can work out. Bye for now.